Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we'll be looking at GCSE Physics gas particle motion. So today I'll explain to you a bit about how gas particles move around and how temperature, kinetic energy and pressure are kind of linked and how they work in terms of motion of gas particles. So without further ado, let's get started. Okay, so the particles in gases move in a haphazard motion. So they are essentially, as far as you're concerned, essentially they're kind of moving around a bit randomly. They move around in many directions. They often change their directions, and things like that. And whilst it's hard to predict the movement of individual gas particles, on a whole, we can predict some average movements. So, using this, we can actually see some properties. We can actually explain some properties of temperature and pressure and kinetic energy and volumes, and we can link it all together using the idea of gas particles in motion. So, let's see temperature first. Long story short, temperature is a measure of average kinetic energy. Because, if we think about it, if we increase the temperature, we are increasing average velocity of particles. The higher the temperature, the faster the particles are moving, the more they are moving. So, by increasing the temperature, we are increasing the average velocity of the particles. And because of that, we are increasing average kinetic energy of the particles. Now, this is explained by the following equation. You probably have come across it. So, kinetic energy is equal to half mass times volumes, kinetic energy is equal to half mass times velocity squared. And that equation actually explains what's going on here. Because if we are increasing the velocity, by increasing temperature, we are increasing the velocity, and because we are increasing the velocity, essentially, guys, we are increasing the kinetic energy. So that's how temperature links in with kinetic energy. Now, work done can lead to increase in temperature, because work done essentially signifies how much energy has been transferred. As you probably know from previous videos or from school, work done is the energy transfer, how much energy has been transferred onto the gas. And if we are transferring more energy onto the gas, we are increasing the kinetic energy stores. And if we are increasing the kinetic energy stores, we are increasing temperature. And often when you do work on a gas, you increase temperature. Even with simple things such as pumping up a car tire, you actually note a temperature increase as you are doing the work by giving those particles kinetic energy and pushing them into that tire. So that's how temperature works. Now, what about pressure, guys? What about pressure? Well, let's first have a look at what pressure actually is. So, particle collisions lead to pressure. Now, what do I mean? So here we have some particles. In blue we have some particles, and in black here we have a side of a container. It can be a tank, it can be some kind of a cylinder, it can be even like a room, any kind of container. And gases exert pressure on the container. Now, if you think about it, pressure is equal to force over area, because pressure is essentially force exerted on a determined area. So, seeing as this is the case, if we have these particles and they are randomly moving around, once in a while they will hit the side of the container. And considering how many particles we have in gas, a lot of them at any given time, a lot of them will be hitting the side of a container. And every time they hit the side of a container, they exert force on that container. And that is pressure. That is essentially pressure. These particles hitting the side of a container, exerting force on it, on the side of a container which has certain area. So P is equal to F divided by A. That's what pressure is. Now, what about how does pressure link in with certain other things? So here we have another equation. Pressure times volume is equal constant. And that equation essentially ties in, that came about from these parts. And here we have temperature. Now, if we increase the temperature in the container, what will happen? You probably know that pressure will increase. And why is that? Because if we're increasing the temperature, we are giving those particles here more kinetic energy. Therefore, they are moving around faster. And if they hit the container, they are hitting it harder. They are hitting it with more energy. And therefore, they are exerting more force on the side of a container. And going with this, that will increase the pressure. That will simply increase the pressure. So that is exactly why when we increase temperature, we will increase pressure. Now, if we increase the volume, we decrease pressure. Now, this may be confusing the first time round you hear me say it. If you increase the volume, you decrease the pressure. And by increasing the volume, I'm talking about increasing the volume, that's increasing the size of a container essentially. So therefore the container is able to hold larger volume. So I'm increasing the space in which those particles are. And because now they are more spaced out, they are less likely to hit the side of a container. And therefore the pressure goes down. So if we increase the volume, the pressure goes down. Easy mistake to make here is that people often think that by increasing volume you mean putting in more of the particles. So, for example, pumping up a pressurized cylinder, right? In this case, you are actually increasing pressure by pumping in the particles. But what you are doing here is pumping in the particles. You are not increasing the volume. So that's the common misconception. Whereas if you increase the volume, the pressure goes down. This is crucial. This is important. This is why I'm repeating it so many times, because it's such a common misconception, guys. Okay, so this equation here that I already mentioned, PV equals K, so pressure times volume is equal to constant. This pressure came about from these relationships where here we have a constant K, and that's constant. And say if constant K remains constant, if we increase the volume, the pressure needs to go down in order to give us the same value for the constant. And if we want to increase the pressure, we need to decrease the volume to give the same value. So that's how pressure works essentially. Now, what about this case? What is all of this about? Well, in some cases, guys, this isn't always. This is in some specific cases. So when we change pressure, we either decrease or increase the pressure, we can change volume. Now, this may sound strange because here I've just been talking about volume and pressure being kind of related. So if you increase one, you decrease the other. But now, if we change pressure, we change volume. So what do I mean by this? So sometimes if we increase the pressure, we can increase the volume. Sometimes this may be the case, but that's in a very specific scenario. That is if the container is stretchy. So the perfect example here is a helium balloon. So here we have a helium balloon and we pumped it up with helium, and then outside we have air particles. And essentially the size, the volume of that helium balloon is essentially decided by the balance of the outside pressure and the inside pressure. If we pump in more particles into the balloon, we are increasing the pressure inside the balloon, so it exerts greater force on the side of a container, causing the container, i.e. the balloon, to expand. and there isn't enough air pressure to counteract that expansion, and that balloon will carry on expanding until the external force, the external pressure placed on the balloon by the air is matching the internal pressure exerted by the balloon on the side of a container. So this is one of the rare cases where you can actually, by changing pressure, you can actually change the volume. So this is it for today, guys. I hope this video helped you understand a little bit more about how gas particle motion relates to key characteristics such as pressure and temperature and volume. So if you found this video helpful, make sure you give me a thumbs up. If you want to stay up to date on more GCSE physics, chemistry, biology and maths videos, make sure you hit that subscribe button below. Don't be shy. Thank you for watching. I really appreciate when you guys watch my videos, and see you next time.